Alright, let's begin. So for this video, we're going to be talking about the network manager as well as the different messages and how they're sent. So to quickly start off with the client side with the network manager, they have to connect via localhost. So that is the main difference between setting these up. So we have the extra IPO host to resolve any issues that may happen when we're trying to connect. Um, when it comes to sending messages, for currently this is the Dead Reckoning setup. So for Dead Reckoning and both Dead Reckoning and Player Prediction, which I can showcase quickly later, we are using Reliable Ordered for our Fire and Mine messages and Unreliable Sequence for the Move messages. For the Move messages, it's fine if we miss some since you're holding that down. If you're holding W, it's going to pick up one of the dozens of W holds from the frame. The issue with fires in lane mine and why I've decided to make them reliable and ordered is to make sure that we do not mix up our IDs during the back and forth process. If the player fires a missile and the server says, or if the player fires a missile in mine in quick succession, and then the server says, okay, that means you've got mine 34 and missile 36 coming right at you, and then those get flipped. Now the client sees that the inverse is the case, and they have mine 36 and missile 34, which would then end up breaking everything. So these two are currently set up as reliable ordered. Um, that is the main difference between them. Um, they both simulate the same thing, and the sending of the messages is the same. Um, if I were to hop over to the server to showcase the other messages types. So for position, we're using reliable sequenced currently. This is for specifically the Dead Reckoning. It's sequenced or reliable sequenced. For excuse me. For the client prediction, we are using unreliable sequenced because we cannot afford reliable sequenced in this version of the in this version. So this is using unreliable sequenced. Uh, Additionally, for contact, the collision message, for this one, I've chosen to use also reliable ordered. And the reason why I'm doing this is to make sure that collisions for missiles happen after the missile's already been created. I was running into some issues where if I tried to ignore any missile collisions, then the missiles would just stay dead on the screen, not moving anywhere because the server's not going to update it. That missile is dead as far as it's concerned. So I have an extra step in my data queue manager, which I will talk about the ordering of the messages a bit more in depth later. But I have it set up so that collisions are added to the queue to send back last. That way, the client can guarantee all of their game options are objects are created, and then the collision will be sent in after that, so they know what to do with each object. Um, as for the actual network manager here, because it's the host, we don't have to do any resolve issues. We just have the server port here for that. Same setup with loss latency and jitter. The other difference for specifically the network manager for the Dead Reckoning is that the player side is responsible for requesting time. So on top of the simulated loss and such in the connected status, we also request the time from the server, and then the server will be able to take this time and then reply with what the actual time is supposed to be. So whenever it receives a request, it will send a time reply, and the client will then be able to take that time reply and update the time. Um, so that is the how the networking is set up. For the actual messages, collisions, we have on the if the objects are not null, then just accept the collision. For the fire message, just call the right one to fire the missile. Mine message, same thing, call the right one to lay a mine. Move message, this one is used by the server. So if I just hop over to the server again. So for move messages, this is just how they know how to move and rotate the ship given which type it is. Um, Position is sent by the server. This sends in what the ID of the object is that needs to be moved, what player belongs to, as well as the angle and position. For the Dead Reckoning version of this, because this is yeah, for the Dead Reckoning version, let me bounce back over to here. This includes having the extra data such as velocity and time associated with it. That is all of these. The Just to bounce back one more time, the fire, lay mine, and move messages are sent by the players once per frame during the update loop, and then the server will bounce these messages back to the clients to say, okay, you're good to fire now. Um, for the actual structure of the messages, I ended up mixing up how packets worked at beginning of the semester. I didn't know Ligwin was going to make their own, so I had my own packet system set up. So network packets, they have a timestamp to use for recording as well as a frame that I was using for debugging. They're composed of a header and a message. The header is associated with all the networking things, such as what type the message is, its destination, its reliability, and what channel to send it through. And then the data message itself is everything that I showcased with all the different executions for everything. So whenever a message is being created, so if I were to hop back here, we end up using the network manager to build the packet. So this will end up grabbing stuff from our factories, initializing them, and then returning it saying that it's ready, and then we can add it to whatever queue we need to add it to. Um, so just because I mentioned the factory, so here's the object pool for the network packets, and then here's the factory for it. Here's the header for the object pool for the header. Here's the factory for it. And then here's the object pool for the messages. And then here is the factory for it. And that's it.